let me move on to my assigned duty to introduce the theme keynote speaker of this session, my friend Dr. Murali Krishna. Dr. Professor A. Murali Krishna joined Department of Civil and Environmental Engineering, Indian Institute of Technology, Tirupati in 2019. He is also serving as Dean, Planning and Infrastructure of IIT Tirupati. Before joining IIT Tirupati, he has he was a faculty member in Department of Civil Engineering in IIT Guwahati since 2008 for about 11 years. Dr. Murali Krishna obtained doctoral degree from Indian Institute of Science, Bangalore, M.Tech degree from IIT Kanpur, and B.Tech degree from Sri Venkateswara University College of Engineering, Tirupati. His research interests include earthquake geotechnics, geosynthetics, and ground improvement, site characterization, and numerical and physical modeling of geotechnical structures. He was a recipient of BRNS Young Scientist Research Award, Boycast Fellowship, and Heritage Fellowship. He was a visiting fellow at Bristol University, UK, Surrey University, UK, and University di Torino, Italy. He supervised 7 doctoral students and 24 master students, co-authored nearly 180 publications of technical papers in international and national journals, conference or seminar proceedings, including chapters. Dr. Murali Krishna is an executive member of Indian Society of Earthquake Technology, International Society of Rock Mechanics, Life Fellow of Indian Geotechnical Society. He is also a member of TC 203 of ISSMG since 2011. He served Indian Geotechnical Society as an executive member for 4 terms, 2011 to 2018 continuously. Dr. Murali Krishna organized several national and international workshops and short courses, in particular Indian Geotechnical Conference 2017 at IIT Guwahati, which everyone appreciated his organizing skill. He is a consultant for several projects as well as a reviewer for several national and international journals. He was chairman or vice chairman of GATE and JAM at IIT Guwahati during 2016 and 2019. With these few words, I invite Dr. Murali Krishna to deliver his theme lecture on performance of geosynthetic reinforced shallow foundations. And,
Yeah, thank you, Professor Bina. Is my voice clear? Am I audible clearly?
yes.
Yeah.
Thank you, Professor Arif, for this session sharing. Let me share my screen. I hope you can see my slide.
Yes, sir. Yes, sir.
Okay. So thank you all. Good evening, everyone. So thanks for the IGC 2020 organizing committee for inviting me to deliver this theme lecture. I'm missing this IGC gathering personally. So because after so many years, this is the first time we are not meeting our peers. There is a lot of gathering. This is what we are missing. But one thing to note, everybody is staying safe and able to join attend the sessions. That's a good thing to note. So coming to my topic, shallow foundations theme lecture, I have chosen the topic of performance of geosynthetic reinforced shallow foundations. This is basically co-authored by Dr. Argadeep, who was my PhD scholar at IIT Guwahati, who is currently working as an assistant professor at Jalpaiguri Engineering College, Jalpaiguri. I hope Argadeep is also here. Argadeep, are you here? You can
yes,
say
sir.
hi. Yeah, hi. Good to see you.
Yes, sir.
Good to hear you.
Thank you.
Yeah. So his main work contribution. So this is how I organized my topic content this way. I'll briefly introduce the need of ground modification, and talk about various options of reinforced foundations. And we'll be discussing briefly about the experimental studies and some performance observations from the numerical model, physical model studies in terms of homogeneous soils, layered soils, and reinforced configurations. And I'll try to highlight the comparative performance and the various mechanisms, and then briefly concluding remarks. As the time is very limited, I just made the presentation very simple, and other relevant information can be obtained from the paper, whatever the thing. The basic objective of a foundation design is to design a safe and economic foundation and substructure, include foundation and the substructure together. So the various aspects involve evaluation of the capacity of the soil to support the loads, and once the foundation sizes are designed, then properly designing the structural element to transmit the load to the soil. This is what the basic objective. So when we consider both the structural element and the founding soil, the foundation system is not only the structural element and not only the soil, it's a combined together. So some soil underneath the foundation also part of the foundation system. So that is the very fundamental of this fundamental aspect of the shallow foundation. So when we talk about various foundations, we have the class of shallow foundations and deep foundations, or combined foundations, where you have the pile raft foundation, where the both shallow foundation feature and deep foundation features would be combined. So these are various types of foundations. So shallow foundations are generally preferred because they are very simple and inexpensive compared to the other types of foundation, for example, deep foundation, combined foundation. So, however, there would be certain instances where the deep foundations would need to adopt it based on the site conditions and structural loads and local availability, right? So, what are the problems and challenges associated with the shallow foundations? If the soil is not strong and stiff soil, then we'll be having a unsatisfactory bearing capacity of the soil, and associated excessive settlement related problems would be there generally. Generally, the designers will tend to adopt the deep foundations in such instances. However, one can go for the ground engineering and ground improvement option. That is where the linking of the shallow foundation and ground improvement things will be there. And various methods are available in the ground improvement for ground engineering. Among them, the soil reinforcement is widely being accepted and being in practice in the last 3-4 decades. We can see several instances, many places, soil reinforcement geosynthetics are being applied. When you talk about the geosynthetics, there are different types of geosynthetics are there. In the strip type reinforcement, sheet type reinforcement, and cellular type cells type 3D reinforcements are there. Some of the pictures of geosynthetics I'm showing here. This is sort of strip reinforcement you can see here, and other things are like planar type reinforcement. This is the geotextile, woven geotextile is here, and geogrids are here. This is the combined geosynthetic material, a planar type geosynthetic material, which is having some drainage medium and also some filter medium together. And other 3D form of reinforcement, or these are the geocells, so which is the cellular form of reinforcement. So it can be of different shapes. You can see the vertical walls are this particular wall is completely closed, so whereas these walls have some perforations of different sizes and all. These geocells can be obtained onto the site like this one, very collapsed form, so which can be extended like this one, and we can open up this one, we can extend, and to fill this material to proceed with the construction. So geocells can also be prepared using the geogrid material like this one. So these are the unfilled, they were prepared. This geocell is a factory-made geocell, which was directly bought and placed. These two and the top two one, they are prepared on the site. The advantage of on-site preparation geocells means they can be prepared to the any different sizes, particularly when we need to use for the very larger areas. However, in the context of shallow foundations, if you see, so mostly the readily available geocells may would suffice the need of the requirement. So now, when we adopt the reinforcing the foundation, what are various options if you want to modify the foundations? Let us see here. So let us take a ground. Hypothetically, I'm taking a case of homogeneous clay or homogeneous ground. However, in practice, no reality, the ground is not homogeneous. There are certain things would be there. And another hypothetical case is taken here is the surface foundation. Otherwise, generally, we will be embedding the foundation to some depth. That is what the practical thing. However, here, the homogeneous soil case and the foundation resting on the surface has been taken. Yes, this foundation soil has some problem, whole system, and we need to improve the capacity. And one option would be first taking the top a few meters or few centimeters of the soil can be taken and replaced with other good quality of soil, generally the sand or other type good cohesionless material, or sometimes M sand or quarry dust. These are the things also can be used to fill the top some part of the soil, so which can be a layered configuration and unreinforced vertical. No other reinforcement has been placed here. So this is one type of configuration one can adopt to improve the capacity of the soil. Otherwise, we can also include some layer of reinforcement in between the interface, a single layer, or we can also use the multiple layers of reinforcement, starting from the top of the bottom of the footing, and we can come to the interface also. That is what more practically can be considered. But however, in this case, we are taking one planar reinforcement at the interface between the two materials is one option one can consider. And the next option is to use the three-dimensional geosynthetic material in the form of geocell, placing directly at the interface. Okay, this is the one more option one can consider for the getting the advantage of the foundation. Here, there are certain parameters were involved. So the U is the top depth of the geocell from the surface, and H is the thickness. Small h is the thickness of the geocell, and capital H is the total thickness of the sand layer. Total geocell reinforced sand thickness we can see, and small p, which is represented as the total width of the foundation, which can be in proportion to the footing. And another option is keeping the geogrid at the interface and placing the geocell over this geogrid is another option one can consider. So these are various options one can adopt for improving the capacity of the shallow foundations using different forms of the geosynthetic reinforcement. To observe the performance of these different model studies, experimental studies conducted by Biswas, Argdeep Biswas, which was defended his thesis in 2016. A very thorough study has been done, considering the different types of the subgrade soils, having different undrained shear strength values of 7, 15, 30, 60 kPa, and also a uniform sand of relative density of 80% has been taken, and a different configuration of the reinforcing foundation configurations are taken as discussed just previously. So various parameters have been varied as shown in this particular table. So for example, thickness of the sand stratum or geocell reinforced sand stratum is represented in terms of the capital H by D as a non-dimensional values here. And D is the capital D is the diameter of the footing, which has been taken as a 150 mm diameter. Is a circular footing has been taken for the preparation of the footing. So like this, various series of tests have been conducted, and I will try to highlight the performance of these different configurations and then comparative performance. So a little bit more into the details of the experimental setup. This is the testing tank of 1 meter by 1 meter size in plan and 1 meter height. And you can see here 150 diameter of the circular footing, and various dial gauges were placed on the surface to monitor the deformation on the surface. And the load has been applied using the hydraulic job. As we saw in the earlier thing, the materials, various materials used in the particular study were clay, having these properties, of course, prepared at different undine and under shear strength Cu values, and sand material having these properties and prepared at 80% relative density. And of course, geogrid as a geosynthetic material, geogrid has been taken. This geogrid has been used as a planar reinforcement horizontally, and also the same geogrid has been used to prepare the geocells and forming a three-dimensional geosynthetic material. So this is the another picture showing the preparation of the sand clay bed, and you can see the picture here keeping the planar geogrid placed on the top of the clay subgrade, and here you can see the geocell prepared using the geogrid. And this picture shows the geogrid has been placed at the bottom, and over that one a geocell was placed. This is how the different configurations. Now let us see the a simple bearing pressure deformation responses in various foundation configurations. Starting with the homogeneous foundation configuration, this is the configuration has to be taken. So as shown in the table, 4 types of the clay subgrades were taken, ranging from 7 to 60 kPa. Obviously, with increase in the shear strength of the soil, we would be getting the higher resistance in the bearing capacity. Same thing can be reflected here. So for this line, this is a sand capacity has been shown here using this particular diagram. Referring to this one can say the sand at 80% relative density is stiffer compared to the clay subgrades up to 630 kPa, and however this sand is softer, means weaker than the clay subgrade of 60 kilopascals. So once these capacity, whatever has been obtained, the bearing capacities, they are compared with the classic theories available for the determination of the bearing capacity. Simply for clay subgrades, the bearing capacity values were compared using the classic equation with NC factor taken as 5.14 Cu. Directly these values are compared here. Reasonably, the experimental values findings were reasonably comparable with the theoretical findings. So next one is the layered for foundation system, as shown in this figure. Here, the thickness of the sand layer H has been varied from 0.63 to 2.17, and the responses were obtained. You can see here for a homogeneous sand, the responses are shown here using this particular graph. And when the layered configuration having the H as a 0.63 times the diameter, a small thickness of the sand layer has been placed. You can see the improvement in the bearing capacity for different clay subgrade values. So among these things, we can clearly identify the particular increase in the capacity in terms of the very soft subgrade here, 7 kPa, the difference we can see, and then 15 kPa subgrade, the difference also we can see significantly. Among this one, the 15 kilopascal subgrade having the layered simple unreinforced sand has been significantly contributed for increasing the bearing capacity. So these are some other height of the sand layers. If you see here, H values are varied from 0.63 to 2.19. And for very soft clay subgrade, how different thickness of the sands contributed in increasing the bearing capacity. And similarly, this figure shows for 15 kilopascal bearing under Cu value, the increase in the capacity for different thickness of the sand layers. From this, you can see for the very soft soil, the thickness is very significant in improving the capacity of the whole foundation. However, for the 15 kilopascal thing, Even nominal small thick layer of 0.63 times the diameter thickness layer also has significantly increased, and further not much change in the capacity up to some 12% of sediment we can see here. This is one observation we can see. So what we can see in a moderately soft soil and not very soft, moderately soft to medium stiff soils, even keeping a small layer of sand will significantly improve the bearing capacity. So the capacity analytical evaluation of this bearing capacity can be compared so with the observations. This is the typical observations what was observed. So when we have the layered configuration, a cone of formation clearly visible, showing the clear penetration here. So these analytical formulations were used in two cases. One is the dense sand over the soft clay. This formulation was used for calculating the capacity up to 30 kilopascals of undent shear strength soil. So whereas this one, the other category condition will come. So where the top one is the loose sand compared to the stiff clay at the bottom. So loose sand means it is not loose sand. So it is relatively softer compared to the soil capacity. Using these equations, the capacity foundation bearing capacities have been evaluated. So these are also reasonably, they are comparable with the theoretical calculations. So next category of reinforcement category is the geogrid reinforced category, which is one layer of geogrid paste at the interface, and keeping the same the height of the sand layers of 0.63 to 2.190, various tests have been done. So this is the unreinforced condition. That means sand has been placed here, but without reinforcement, how the bearing capacity, and with reinforcement, how the capacity has been increased at 0.63 times the diameter, okay, depth. This is the significant improvement we can see here. So the difference between these two lines clearly provide the what is the contribution of the geogrid reinforcement in enhancing the foundation capacity. So this figure shows the for various CU values. So for example, CU 7 kPa, even CU 60 kPa, and having the sand bed and also having the geogrid reinforcement at the interface. So we can see the significant improvement in the bearing capacity. Just to wanted to take your attention here. So even you see here, even the very stiff subgrade of 60 kilopascals of strength could get the improvement when we use the geogrid at the interface. We can see that improvement also can be obtained. The reinforcement mechanism in this case can be explained with reference to the membrane effect, which has been reported earlier by Love et al. And various other researchers who has conducted the studies. And